Today, here's the video for Lesson 5, Module 2. Previously, what we had looked at was tape diagrams, where you were taking, for example, if it was 7 of a number of days, and each one of those days a person received $3, then you would have your tape diagram. It would look kind of like this. I'm going to go ahead and draw it up here just to kind of remind you. And if you had 7 of these, and these are going to make 6 lines, 1, 2, 3, 4, 5, 6 lines, and then we pretended if each one of those happened to be worth 3, then we thought, well, let's see, 3 times 7, that must be that this is worth 21. And then if we said, okay, so how much for 3 more days in that case? And then you're thinking 3 times 3 would get you 9. So then you're kind of filling in those blanks. This time around, however, we are looking at moving from those tape diagrams to something called an area model. And we have done area models some in class, and we're going to go further with those today and get a little bit more complicated with them. So are you ready? Let's grab our pen. And I'm going to go ahead and stick with green today because it's just kind of a fun color. Today's a Sunday. So it says draw an area model and then solve using a standard algorithm. Standard algorithm, also known as parent method. So use arrows to match the partial products from the area model to the partial products. Partial products. I'll talk about that in the algorithm. So in this case, if we have an area model, and we're going to say that we've got a box, and we have 2 things going on here. So we're taking 24, and we're saying 24. What do we have in the ones place? Just a 1. So we're going to multiply. How many 24s? Here's one of them. 1 times 24. But then we're also going to be saying 20 times 24. We're going to take that number apart a little bit. We know pretty easy, known for a long old time now, if you have one set of 24, yep, you have 24. Now this one we can think about, if we're saying 0 times 24, how much is that? That is 0. And now we can think 2 times 4 is 8. 2 times 2 gets us 4. And so now when we think about this, here's the parent style. If we say 24 is the number up top, and then we say times 21. Oh, and look at, I'm duplicating what's already here. So I'm going to undo that. Let's get rid of it. All right, get the pen back. Here we go. So now, what we did before, we were starting with the 1, and we said 1 times 4 is 4, and then we said 1 times 2 is 2. And look, the 2 is in the tens place. 1 times 2 that's in the tens place puts a 2 also in the tens place. Now, because we're moving on, we'll erase that little arrow so we can do the next thing. And so now, this time, I'm going to use a different color. Let's get some blue. So this time, what I'm looking at here is 2 in the tens place. 2 is in the tens place, so I'm going to fill in the ones place because we're looking at the tens place now. 2 times 4 is 8. And when you think about that, 20 times 4, you can count it out loud and go 20, 40, 60, 80. How many is 4 20s? It is 80. Now we're looking at 20 times 20. And so we say 2 times 2 is 4. And we think about it, 20, 40, 60, 80, you could count to 20 times by 20, but that's going to take you a while. So if we think about that, and we say 2 in the tens place times 2 in the tens place, we know that both of these would be zeros, right? 20 times 20, let's see what it would look like going kind of back the way we've been looking at things. with place value. We know that 2 times 2 is 4, and how many zeros are we throwing on the end there? 2 of them. So 4 is in the hundreds place. Here's 4, and it happens to be in the hundreds place. So here's what's happening with this. This is your partial product. Because this is the product, the result when you multiply 20 times 24. And that's what we got here. And then this one right here, that's the partial product of those two. And now just like when we multiply, it's repeated addition. Remember? 8, 9, 10. We make our 0. We carry our 1. 4 plus 1 is 5. So 504. And when we look over here at this, we've got 4 in the ones place, 0 in the ones place, nothing to combine. 8 plus 2 is 10. So we carry. But there's nothing in the hundreds place in this case. 4 plus 1 is 5. And that's why they match. Alright, let's do another one. Actually, let's go ahead and take a look down here. Well, no, let's go ahead and do another area model, just because. That way you're firm with it. So in this case, we're going to make our rectangle. And what are we saying? We're saying 242. 242. If I can get my line there. 242. And what are we multiplying by? 1 in the ones place. So we're saying times 1. Super easy, huh? And then we're saying times 20. We know 1 times 242 is 242. We look over here. Let's do the same thing. 1 times 2 is 2. 1 times 4 is 4. 1 times 2 is, again, it's a 2. So now let's take a look at this one. 0 times all of that is 0. 20 times 2 is 40, right? So here's another way to look at it, is here's the 0 because you're saying 20 times it. So there's not going to be anything in the ones place. 2 times 2 is 4. And then we say 2 times 4 is 8. And the same thing is happening over here. We went and we said 20 times 2 is 40. And now we're thinking 20, if we're saying 2 times 4 gets us an 8. Oh dear. Come on back. That's an 8. And then we got 2 times 2 again, and that's a 4. And so when you think about that, this is 4,840. This right here, if you have 4 of these, you have about 1,000, don't you? Well, that's going to be pretty big then, right? All right, let's take a look here. So we went 2 times 2, we got a 4. 2 times 4, we got an 8. We go 2 times 2, we get ourselves another 4. When we add them together, 2 comes straight down. 4 times plus 4 is 8. 8, 9, 10. Carry our 1. 5,082. Same thing happens over here. The ones place. 2 plus 0 is 2. 4 plus 4, they're both in the tens place, so the 8 lands there. 8 plus 2, we carry our 1. 4 plus 1 is 5. So they match each other. Here is times 1. The partial product matches right up. So now what we're going to do is we're going to take a look at the word problems. A young snake measures 2,300 meters long. During the course of his lifetime, he will grow 13 times his current length. What will his length be when he's full grown? Let's make our area diagram. So he right now is 2,300 meters long. We're saying that he's going to be 13 times that. So let's take that apart. Here's the ones place. Here's the tens place. 10 plus 3 is 13. Now when we work this out, we can say 3 times 3 is 9. 3 times 2 is 6. And we know that right here, if this is 23 hundredths, this doesn't overflow. If this was a 10, it would overflow into this. If this became a 10, it would overflow into the ones place. So these are going to stay right where they are. Now we say 0 times all of that. And we're going to be saying 10 times it. We know that 10 times the tens place means it's going to be a 1, or it's going to move to the ones place, right? So this one now, if we say that 0 right there, that's the hundredths place, right? So this becomes your 3 right here. And then we've got our 2. And because of the overflow, we know it's moving around a wee bit. And so our 2 lands in the ones place. Let's double check it with standard algorithm, shall we? Let's do it parent style. And so in this case, if we have 0.23, we're saying times 13. We know 3 times 3 is 9. 3 times 2 gets us a 6. 10, oh, I've got to have a 0 so that we move to the tens place. 1 times 3 is 3. 1 times 2 is 2. Now we get into our addition. 9 comes straight down because we're combining it with 0. 6 and 3, that's another 9. Here's our 2. How many place values did we have in here? There's 2 of them. So if the decimal is here, it's going to move 1, 2 places. So it's going to be 2 and 99 hundredths. Let's combine this. 0 plus 9 is 9. 3 plus 6 is also a 9. Get my pen where it'll work for us. That's going to be a 9. And then we've got this 2 that's just going to slide on down. So now they match. So he will be 2, let's get the pen to work here, 2.99 m for meters long. When full grown. My pen is not cooperating. Full grown. Period. Alright, so that's using both your standard algorithm as well as your area model. Here is our homework problems for today. And it says right there with a nice little happy face, pick one. What I'd like for you to do is pick one of these, bring your answer to class on Monday morning, draw an area model, and then solve using, oh sorry, don't bring it Monday morning, bring it Tuesday morning, my mistake. Draw an area model and then solve using the standard algorithm. So these ones, just like I started with, you'll be doing both. Thanks.